Okay, so look at problem number 1 on our chapter 4 review. It says that it wants us to go ahead and sketch a right triangle corresponding to the trigonometric function acute angle theta. Use the Pythagorean theorem to determine the third side, and then find the indicated function of theta. Tangent of theta equals the square root of 2 over 4. Find the sine of theta. So the very first thing you want to do is just go ahead and sketch a right triangle. And remember, when you're sketching your right triangle, just remember that put it in standard position. So that means that theta right here is coming off of the coordinate system. And then once you have theta established, remember the side that is opposite is over on the far side. And then you've got the adjacent side, and then you've got the hypotenuse. That's what your right triangle is going to look like. So now just remember that the definitions, you can go ahead and use SOHCAHTOA. And sine is equal to opposite all over hypotenuse. Cosine of theta is equal to adjacent all over hypotenuse. Tangent of theta is equal to opposite over adjacent. And then you also need to remember your Pythagorean theorem. And your Pythagorean theorem is a squared plus b squared all equals c squared. So using those three things, we can go ahead and establish our right triangle. So looking at your right triangle right here, it says that the tangent of theta is equal to the square root of 2 all over 4. So remember, tangent is opposite all over adjacent. So I'm going to put the square root of 2 on the adjacent, on the opposite side, and 4 on the adjacent side. And then once I've got that done, I can go ahead and use my Pythagorean theorem to find my hypotenuse, because this is the sine that I'm looking for. And sine is opposite all over hypotenuse. So I go ahead and substitute those numbers into the Pythagorean theorem. So here's 4 squared plus the square root of 2 squared all equals c squared. So 4 squared is 16, square root of 2 squared is going to be 2, so all equals c squared. And so c is going to equal, c squared equals 18. Take the square root of both sides, and c is going to equal 18. Break that apart as the square root of 9 times the square root of 2. And then the square root of 9 is going to be 3, and square root of 2. And now you've simplified your c. So now that I've done that, just go ahead and put in that side c as 3 square root of 2. And once you've done that, now you've got all three sides. 4 for your adjacent side, square root of 2 for your opposite side, 3 square root of 2 for your hypotenuse. Then we substitute in, because sine is opposite all over hypotenuse. So opposite, square root of 2. Hypotenuse is going to be the square root of 3 all over 2. If I simplify that down, notice the square root of 2's cancel out, and you're just left with 1/3 for your answer. That'll be number 1. This is going to be the answer of 1/3. Okay, now in this next problem, it just wants to go ahead and sketch this graph of y equals 2 cosine of 4x. So to sketch this graph right here, y equals 2 cosine of 4x, just to remember, the amplitude is how high and how low the wave oscillates. Or if you want to kind of think of it this way, it's your y values. And then we've also got a number in front of our x, so we're going to divide all quadrantals by 4. So I'm going to find my first quadrantal is pi over 2, divide that by 4, and I get pi over 8. I got pi over, and then divide that by 4, and that's just going to simplify down to pi over 4. 3 pi over 2 divided by 4, that gives me 3 pi over 8, and 2 pi over 4 simplifies down to pi over 2. And remember, you can use that other pattern of pi over 8, 2 pi over 8, 3 pi over 8, and 4 pi over 8, and then just simplify those down. A reminder, cosine starts at 0 in the amplitude, then oscillates to 0 in its amplitude, forming a wave graph. So go ahead and write down our quadrantals as our x-coordinates. So here's pi over 2 that we divide by 4 and got pi over 8. So that's our first quadrantal. And then took pi over 2 divided by, pi divided by 4. And then becomes our second quadrantal. Our third quadrantal, 3 pi over 8, and then pi over 2. Now if you're given a graph, and that graph on your test, on your review, already has different increments, and you can just draw your own graph, you can just relabel them. And then don't forget to put in the negatives. So we've got negative pi over 8, negative pi over 4, negative 3 pi over 8, and then negative pi over 2. Once you got those negatives put in, go ahead and put the first dot for this cosine wave. So remember up here, our amplitude was 2. So remember, cosine starts at this amplitude. So this is going to be 2 right here. And it's going to oscillate down to 0, down to -2, back to 0, to carry the pattern on through. And once you've got that pattern established, then just go ahead and draw in your graph. And that's what your cosine wave is going to look like. Okay, on this next problem, on number 3. Number 3 says, express the angle in degree measure. And they're going to give you this angle right here that is in radian measure. And then you just have to remember that pi equals 180. Substitute 180 degrees in for pi and simplify. So this pi I'm going to replace with 180. I'm going to simplify that down. Now to simplify that down, you can just go ahead and simplify it down using your calculator. So you just take your calculator and just go ahead and type in, hit alpha, F1, hit your fraction key, type in 5, and then times 180, and that's going to be all over 7. Hit enter, and it reduces it down to 900/7. Then just take 900, divide by 7, change it to a decimal, and you get 128.57. Number 4. Number 4 says rewrite the indicated trigonometric function in terms of the angle's reference angle. Use the same function. So just as a reminder, to find reference angles, you're going to add and subtract 360 degrees and 180 degrees as many times as necessary to get the angle between 0 and 90, which is the definition of a reference angle. So remember, reference angle is any angle between 0 and 90. So that means that I can take 180 degrees plus or minus the angle, which is what theta stands for. And I can take theta, which is the angle plus or minus 180. Then I can take 360 plus or minus the angle, and plus or minus 360. So I'm going to take my negative 210. I'm going to add 362, it gives me 150. Well, that's definitely not between 0 and 90. So I'm going to do another one. I'm going to take 180 minus 150, and I'm going to get 30. So 30 degrees is its reference angle. So that means the tangent of 30 degrees is going to have the same answer as the tangent negative 210, except for it might be positive or it might be negative. So we've got to go ahead and find the location of the original angle to decide if it is positive or negative. And to do that, we need our chart over here, because in our chart it's going to tell us where the sines and cosines are positive and negative. So remember, in quadrant 1, sine is positive because it's the y value. Cosine is positive because it's the x value. And tangent, looks like we've got to draw this little line here, so that's going to be also positive. Second quadrant, sine is positive, cosine is negative, tangent negative. And I just like to remind myself of their reciprocals right next to them, because that'd be cosecant, secant, and cotangent. They take on the same values as their sine, cosine, and tangent. And then in the third quadrant, sine is negative, cosine is negative, tangent is positive. And then the fourth quadrant, sine is negative, cosine is positive, tangent is negative. So we're going to go ahead and take 210 degrees. I'm going to find out which quadrant it's in. So remember, you're going backwards. So this starts at 0 degrees. And then down here would be negative 90. And when I get over here, it's negative 180. And then up here is negative 270. And a full rotation, negative 360. So negative 210 is going to be somewhere right in the second quadrant. And so since 210 is in the second quadrant, that's going to take the value of tangent in the second quadrant. And it looks like tangent in the second quadrant is going to be negative. So my answer is going to be negative. So that equivalent value would be negative tangent of 30 degrees, and that would be known as its reference angle. On number 5, got a story problem here, so let's take a look at it. We'll go back to our review and take a look at number 5 and read it together. So number 5, it says, your football has landed at the edge of the roof of your school building. When you're 25 feet from the base of the building, the angle of elevation to your football is 21 degrees. How high off the ground is your football? So to go to the solution guide here, what you're going to want to do is you're going to want to draw a triangle representing the problem, then use SOHCAHTOA to solve it. So notice that in this case right here, we've got our school building right here. Just make a rough little sketch right here. And it says that I am 25 feet away from the base of the building. So I go ahead and label this 25 feet right here. Scroll up just a little bit so we can see a little bit better. And then notice also, it says that the angle of elevation to the football is going to be 21 degrees. So I'm going to use my SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent all over hypotenuse. Tangent is opposite over adjacent. So working from the 21 degrees right here, I notice that this is opposite all over adjacent. So that means I'm going to set up using my tangent ratio. So the tangent ratio that it matches is the tangent 21 degrees is the opposite, which is x, is which one I'm looking for, all over adjacent, which is how far away I'm away from the building, which is 25. Okay, now I just got to multiply both sides by 25. So when I multiply both sides by 25, you're going to notice that I can go ahead and solve for x. So I just got to take my calculator and take 25 times tangent 21 degrees. So I'm going to take my calculator, and I'm going to go ahead and check to make sure that I'm in the correct mode. So notice I need to change the degree mode, because that was what the angle was given to me in. Once I'm done changing that mode over, go ahead and type into my calculator 25 times the tangent of 21, and then hit enter, and it comes out to be 9.596. So I just go ahead and round it off to 9.6, and that is how tall that school building is 9.6 feet. Okay, this next problem on number 6. Number 6 says, find one positive angle and one negative angle that are coterminal with a given angle. So just remember your definition of coterminal angles. So the definition of coterminal angles are angles that share the same terminal or ending side. That means that these angles are a full circle rotation from each other. So if you just add and subtract 2 pi from the angle, that means you'll have this coterminal angle. So the definition says I'm going to take my angle, which is theta. I'm going to add and subtract 2 pi. And so that's what I'm going to do with this problem right here. I'm going to take negative 4 pi over 3 plus 2 pi. So now remember this is over 1. Need a common denominator, so I'm going to multiply by 3. So that gives me 6 pi over 3. I'm just going to add my numerator. Negative 4 pi plus 6 pi is 2 pi. Keep the same denominator, which is 3. That's the laws of fractions. So same thing right here. I'm going to go ahead and subtract 2 pi from it. So we have negative 4 pi over 3 minus 2 pi. So again, this is over 1. I'm going to multiply both top and bottom by 3. So when I do that, I get 6 pi all over 3. I'm going to take negative 4 pi minus 6 pi, which is going to be negative 10 pi. Keep the same denominator, which is 3. And so my two coterminal angles I've got is 2 pi over 3 and negative 10 pi over 3. Okay, on number 7, it says use a calculator to evaluate this function. And it says we've got the secant, and they give us 78 degrees, 11 minutes, and 58 seconds. So remember, there isn't a secant key on your calculator, so you have to use its reciprocal, which is cosine, because the cosine key is also on your calculator. Also remember to change 11 minutes to a decimal by dividing it by 60, and 58 seconds to decimal by dividing it by 3600. Make sure that you are in degree mode. So remember that to change to decimals, I got to rewrite this as 11 divided by 60, and 58 seconds is 58 divided by 3600. Because remember, the old British system was based on a clock, so there's 60 minutes an hour, so we change to decimals, we've got to take 11 divided by 60. 58 seconds, we've got to divide that by 3600, because there's 3600 seconds in an hour. So all you have to do now is just take your calculator and make sure you type it in correctly. So first thing you want to do is check to make sure that you're in degree mode. And it looks like that we are. So once we're on degree mode, we're going to type in our calculator 1, divide by, and then we're going to type in the cosine. And we're going to put 78 plus, just put parentheses around your 11, divide by 60. And then plus, and we're going to take 58, and I'll put parentheses around that. So parentheses around 58, divide by 3600. And parenthesis and parenthesis. Hit enter, and it looks like that answer comes out to be 4.8898. Okay, on this next problem, on number 8 says, it wants us to evaluate the sine, cosine, and tangent of the real number, and it says to use a calculator. So all we have to do is just type this directly into our calculator, make sure we're in the correct mode. So we're just kind of typing the sine of negative 5 pi over 7, cosine negative 5 pi all over 7, and tangent negative 5 pi all over 7. So take your calculator and just type it in, make sure that you check your mode. So change this to radian mode. Once we're done doing that, go ahead and just type it in directly into your calculator, exactly as you see it. So type in sine, type in -5 pi divided by 7, hit enter, and it looks like it comes out to be -0.7818. Type in the next one, so we'll have a cosine, and then type in -5 pi divided by 7. Hit enter, and it comes out to be -0.6235, just rounded that off. And then type in the next one, we've got the tangent, and then we've got -5 pi divided by 7. Hit enter, and it rounds off to 1.2540. Now number 9, it says cosine of theta is equal to 2/5. Find the cotangent of theta. So here's our cosine of theta is equal to 2/5. Wants to find the cotangent of theta. So we're going to draw a right triangle and use SOHCAHTOA with the Pythagorean theorem. So remember, sine is opposite all over hypotenuse. Cosine is adjacent all over hypotenuse. Tangent is opposite over adjacent. The reciprocal is cosecant of theta is hypotenuse all over opposite. Secant of theta is hypotenuse all over adjacent. Cotangent of theta is adjacent all over hypotenuse. So we just need to go ahead and draw a right triangle. So here's our right triangle that we drew right here. So notice we know that we got the cosine, which is going to be adjacent. So the adjacent is 2, hypotenuse is 5. Use the Pythagorean theorem, a squared plus b squared equals c squared. So I've got 2 squared plus b squared all equals 5 squared. So I've got 4 plus b squared all equals 25. And then b squared is going to equal 21 when I subtract 4 from both sides. So b is going to equal the square root of 21. So now that I have that right there, I just have to remember the cotangent of theta. And the cotangent of theta, by definition, is adjacent all over the opposite. So here's the adjacent, which is 2. Here's the opposite, which is the square root of 21. Go and rationalize both numerator and denominator by multiplying by the square root of 21. And I get the cotangent of theta equals 2, square root of 21 all over 21.